डियर स्टूडेंट्स अस्सलाम वालेकुम। लास्ट लेक्चर में हम बात कर रहे थे एप्लीकेशंस ऑफ गाज लॉ की, तो अभी हम उसी को कंटिन्यू करते हुए अदर एप्लीकेशंस देखते हैं। तो फर्स्ट एप्लीकेशन ऑफ गाज लॉ वाज टू फाइंड इलेक्ट्रिक फील्ड इंटेंसिटी inside a hollow sphere that was zero. The electric field intensity in the interior of the hollow sphere was zero because no charge was present within the surface of the sphere. Today is to find electric field intensity due to an infinite sheet of charge. Suppose we have a sheet of positive charge uniformly distributed on the surface. For the surface charge density is surface charge density, and the surface charge density is equal to sigma is equal to q over a. Sigma is surface charge density while q is the total charge enclosed on the surface and a is the area of the surface. So sigma is equal to q over a as shown in the figure. So total charge will be calculated by sigma times a. If sigma will be multiplied by a, then this will be equals to the total charge enclosed within the surface. So let we continue. So let we have a positively charged surface and we want to calculate electric field intensity at point P on both sides of the surface as shown in the figure. To calculate this, let we have a Gaussian surface in cylindrical form such that the point P lies on the surface of the cylinder as shown in the figure, the top surface on both sides. तो फ्रॉम द फिगर हम आसानी से देख सकते हैं कि इलेक्ट्रिक फील्ड इंटेंसिटी और सरफेस नॉर्मल एरिया की जो डायरेक्शन है एट दिस पॉइंट एट दिस कर्व्ड सरफेस दैट इज़ पैरेलल. सो फाई विल बी ई ए बिकॉज थीटा इज ज़ीरो बिटवीन ई एंड दिस surface area, but for the curve this surface, the direction of E and surface area is perpendicular, so electric flux through this surface will be zero or the minimum. A finite part of the sheet, this sheet is shown in the figure. To calculate electric field intensity at a point P close to the sheet, imagine a closed Gaussian surface as in cylindrical form. From symmetry we can conclude that E points at right angle to end surfaces and always from the plane. Since E is parallel to the curved surface of the cylinder, so there is no contribution to flux through the curved surface of the cylinder, as we have already discussed that through this surface of the cylinder the flux distribution is zero. The only distribution is along this surface. So the total flux through these 2 points will be 2EA, as one EA from this surface this side and the other EA is from this side as shown in the figure. So total flux through this Gaussian surface is 2EA. Also by Gauss law we know that the flux through a closed surface or through a Gaussian surface is 1 over epsilon naught times the total charge enclosed. So mathematically this is equal to जी मैथमेटिकली phi through this Gaussian surface is phi is equal to 1 over epsilon r times the total charge enclosed by closed surface. From surface charge density, the total charge was equal to sigma A. This is the value of the total charge as we have discussed earlier in this lecture. So total flux through this surface, this Gaussian surface, will be 1 over epsilon r times the total charge, and that charge is sigma A. So flux will be sigma A over epsilon naught. Also, combining these two equations, we have 2EA is equal to sigma A over epsilon naught, and E is equal to sigma over 2 epsilon naught. Also in the vector form, if we see कि जो इलेक्ट्रिक फील्ड इंटेंसिटी की डायरेक्शन है वो आउटवर्ड है टू दिस सरफेस or normal to this surface. So in vector form, electric field intensity will be sigma over 2 epsilon naught r unit vector, where r unit vector is normal to the sheet directed away from it. So this is clear from this figure. The direction of E will be normal to the surface. So we have calculated electric field intensity through a positively charged, uniformly positively charged surface at a point P. Third application